Bonjour, and welcome to Wahsa Citizens Education Center's radio Zoom classes. This is SVN3E, Grade 11 Workplace Science, and I'm the teacher, Bronwyn Slate. If you'd like to participate live today, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM and also on the television at Bell Express View Channel 972. You are always welcome to join me live through the Zoom link, which is available from me, your teacher, and also your DEC. Our classes are scheduled from Monday through Thursday from 10 till 11 in the morning, and we are in our 7th week of our 9-week course. You definitely should be submitting work at this point. So a reminder, the key questions are listed at the end of each of your IL lessons. You need to do all of them. Some are check your understanding questions, some are activities, and some are review questions. Please explain your ideas and thoughts in complete sentences and make sure you're actually answering the question that is being asked. You can do this by hand or electronically. If you're going to do it by hand, you're welcome to write in your workbook. It is yours to take notes or to write in, but the spaces for the review questions in particular are not very large, so I strongly encourage you to write on a separate piece of paper in order to hand in your work in a clear way. If you're going to hand it in electronically, PDF, Word, and Google files are the easiest ones for us to access. Google Doc files everyone has access to through their NNEC email address, and we're happy to walk you through how to do that if you need help. If you need to use a different type of file, most likely it is fine. Just let us know so we can make sure we can open it. So how do you submit your work? There's 3 different methods. The first is to send your work in electronically. If you've done it by hand, you can scan it with a device. The Apple devices have a Notes app that comes with it for free, and the Android devices have a Google Drive app that comes with it for free. So you can use those to scan if need be. If you need to take pictures, that's fine. They're just scanning it are smaller files and a little bit easier for us to manage. Then you can send it to studentwork at nnec.on.ca, and you need to CC it to John, who is the course marker now. His email address is jstradiotto@nnec.on.ca. The second method is to drop your work off in Sioux Lookout at our location at 74 Front Street. We're the bright red building next to the post office, and we have a small white mailbox next to our side entrance. We are not yet open to the public, but hopefully soon. For now, just continue to put your work in that mailbox and we'll get it back to you as soon as we can. The third option is to hand your work into your DEC. Your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. If you'd like to connect with me through social media, both my Facebook and my YouTube channel are under the name B Slate Wahsa. If you friend me on Facebook and subscribe to my YouTube channel, you'll get notifications every time I upload one of our lessons. All of our radio Zoom classes are recorded and uploaded to YouTube under a playlist called SVN3E, and all of our supplementary videos that are available on YouTube are also listed there so you can access them from their primary sources. Science is really visual. I incorporated as many videos, diagrams, charts, graphics, illustrations that I can in order to really help understand what it is that we're talking about. So I strongly encourage you to access the videos, either joining me live through Zoom or accessing the YouTube videos on your own time. If you do not have access to reliable internet, this is completely understandable. So please just let us know and we can send you a copy of all of our recordings. If you have any questions or concerns, please reach out to us here at Wahsa. We are here to help. If you want to talk directly about the course material as according to these videos, please contact me. My email address is bronwyn.slate@nnec.on.ca, and my Facebook is bslate Wahsa. If you want to talk about something related to the assignments or marking, contact John, and his email address is jstradiotto@nnec.on.ca. You can call us both at the main office at 807-737-1488. Extension 2209 is my extension. 2210 is John's extension. You can also call us toll free at 1-800-667-3703. John's office hours are Monday through Friday, 8:30 to 3:30, although he takes lunch from 12:30 to 1:30 and is not available then. I think it's really important to position myself within the context of this course, as my educational experience shapes how I teach. I have white settler ancestry. I have white privilege, and this has shaped how I experience education, making it easier for me and I'm having less barriers than other folks. I recognize this, and while I cannot change that, I continue to work towards disrupting this cycle and making changes to our education system. I live in Northwestern Ontario on the traditional territories of the Anishinaabe people, and I work to incorporate this culture and knowledge into our science courses. As an educator, I have lots to learn and unlearn, and this is a lifelong journey that I'm committed to, though I will make mistakes. Our textbook is also Eurocentric, meaning that it centers the white experience in both the communities that it showcases and also the scientists that it refers to. It ignores Indigenous, Inuit, and Métis knowledges and experiences, and this is problematic and disappointing. Unfortunately, I've not been able to find another resource, and when I'm no longer responsible for this course at the end of term 1A, it will not be my job and my priority to find this. Hopefully, Wahsa will continue to look for more meaningful resources.
So we have talked about different species and how we identify them or how they're different and work within an ecosystem. Today, in lesson 20, we are going to talk about how we measure and monitor those species and their biodiversity so that we can continue to learn and make sure things are doing all right for various species. So our learning goal is that at the end of this lesson, you will be able to describe common methods of measuring and monitoring biodiversity in various habitats. So you know you've done this because you can explain the differences between quadrat, line, transect, and aerial photography sampling. You can explain and calculate the Lincoln index, and you can describe the alphanumeric wildlife radio tracking and GPS methods of tagging and tracking. So, according to your workbook, which was published in 2010, so that's 12 years old, which isn't a huge amount of, it's not really, really old compared to some things that I'm working with, but it's a little bit old. Things are changing. Things are moving. In Canada, there have been 71,000 species of plants and animals that have been identified and listed, so recorded about. But we know that there are many more still undiscovered. So most of the larger organisms, like mammals, birds, and trees, have been almost completely identified. We can see them. They are easy to find and easy to track and see if they're different, and so we are easy to record information about them. But it's the smaller creatures that account for most of the unidentified species in Canada. For example, over 1/5 of all the species in Canada are insects, and we don't know what they all are. There are estimates of how many species of the more obscure groups, such as the nematodes, I don't know what that is, are a little more than guesses. We really don't know. We're sort of speculating based on other patterns, because we're not able to count them or track them in the same way. So here is a list of some of the larger groups of species. So again, this is not an extensive list at all, but you can see how fungi, we know of 11,800 different kinds of fungi, and there's an estimated 3,800 of fungi that we still don't know. We know over 3,800 flowering plants, and about 75 we think that we don't know. Coniferous plants, we know we have tracked 34, and we think that there's 0. We think that we know all the coniferous plants, which I would assume are trees. And then other plants, we know about 1,100, and there's about 60 they think that are unrecorded. So this continues with sponges, mollusks, arachnids, crustaceans, Insects, insects are, we know 18,530, and we still think we don't know 11,800. So that's still a lot that we don't think we know. Fish, amphibians, we think that there's 2 amphibians that are unrecorded, which kind of seems ridiculous to me in terms of this list. It's like, if you know that there's 2 that you haven't recorded, then how come you haven't recorded them? But I don't quite understand how this list is generated. This is just sort of giving us a general idea. Then reptiles, birds, and mammals, we think that we know all of them, and that there's none that are left to be recorded in Canada. So how do we know that we know them or we don't know them? So in order to measure and monitor species biodiversity, researchers use different estimation methods. So they also use different technologies to measure species populations, sizes, and that's what we're going to be looking at today, about how we're able to create lists like that when we're saying that we don't know all of them, or that we know how many of a certain amount of things are, which we didn't look at, but how do we even guess that when we can't count everything? So we're going to look at sampling, which is how we count things in science. So sampling is a way to measure and monitor biodiversity. So researchers monitor species biodiversity by collecting and analyzing repeated data and observations about the number of different species within a given area over a period of time. So doing this allows them to evaluate any long-term changes in the number of different species. So this is how tracking, counting, and collecting information about the various species, and then returning to the same space a period of time later, means that we can then see how things are changing and what is going on. Even within geographically small habitat, it is difficult to go out and count each and every species that lives within it. Instead, researchers take samples of species within a habitat. Sampling is a way to give an estimate of the number of species in a given area instead of counting them all. So sampling means that by nature, we aren't assuming that we are going to exactly count everything. Everything is an estimation, but we're able to get a good approximation based on the information that we do count. So let's look at a couple of different types of sampling. So first we're going to look at quadrat sampling. So this is when a series of gridded plots are placed into a habitat. Then researchers identify, measure, count, and record data about the species within the plot. It can be placed randomly throughout the study area, or it can be in planned locations. The shape and size are uniform throughout a study. So if you're going to decide that you're going to do 1 meter squares, then you're going to continue to do that for the entire study so that you have a uniform measurement tool. But from study to study, your quadrats, could be square, they could be rectangle, they could be circular. They don't have to always be. It's not like there's one uniform measurement that is like, this is the only way to do quadrat sampling. No, you just want to be uniform within your own study. Your quadrats can vary in size, but often they're roughly 1 meter squared, just in terms of a general idea of how big they are. So not only are the different types of species counted and recorded, but the abundance is also measured by counting the number of species of each species found in a quadrat. So you know, oh, I picked a spot where there are dandelions are busting out. So that the fact that it's not just one dandelion, it's 100 dandelions is different than in a space where there's just one dandelion. So that is part of the information that's recorded. Here are 2 pictures of quadrat sampling. So you can see that they can be really different sizes. We have a small one here that looks like it could be like maybe 2 feet by 2 feet. And that they're looking just in a grassy sort of area and noting the plants in that area. And here is another one that is maybe, I don't know, maybe it's 1 meter by 1 meter, or maybe 1.5 meters by 1.5 meters. And then even within that, there are further little quadrats or little divisions inside of there to further analyze and get that information about the species that are in that area. So it can be either passive or active sampling. So it depends on the organisms and the habitat being studied, which one you would choose. Generally, these first types of samplings are good for species that don't move. So either plants, lichens, mosses, things like that, but also like mollusks or barnacles or other animals that are stationary. But still, passive sampling is when none of the organisms or plants are removed. Everything stays, you're just looking. So researchers carefully sort through each quadrat by hand, or they can take photographs for future analysis. So they're not picking plants, they are just looking at them and noting them without really disturbing the area too much. Active sampling is when the organisms and plants found within the quadrats are collected for later identification. So this is often used when researchers are estimating the population of an organism within a study area. So that's just how you might choose which to do. So now we have line transect sampling. So this one, researchers lay down a long string or rope across a study area. The data is then collected either continuously along the line or at intervals along the line. So it can just be the whole line, or it can be every 5 meters or every 4 feet or something like that. It can be used on its own, or it can also be used in combination with a quadrat sampling. So you could have your line laid out, and then you could be using quadrats at those every certain intervals. Researchers record and count species over, under, and touching the line. They might also record species they don't see but expected to see. Often when there are obvious geographical differences in the study area, the line might be laid out over a river or through a forest into a field. So if you're looking in an area where there are distinct differences, having that continuous line where you may, you'll be able to know where the changes are can be helpful. So here is a image. I wasn't able to find a great image. I wasn't super happy with this, but I guess it's hard to just like draw a line in the world. So here is a forest area, and then this is the transect line, and the researcher who's walking along it and collecting information. So basically that is what it is. And then we have aerial photographs. So sorting through quadrats by hand is often too labor intensive. So if you can think back to those previous pictures and that small amount of space that they were looking and finding, like that was packed full of plants and who knows what we couldn't even see, that's pretty time intensive to be able to spend the time and the labor to go through those throughout an area and really get a lot of information. So they really don't translate that information very well to a large area for biodiversity. Instead, this is where aerial photographs are often used. So there are common types of film used in aerial photography, but it could be black and white, infrared, or color. So it's not like you just have one way to do it. Depending on what you're looking for, you might use different types of films to take your pictures. So black and white and color hopefully are fairly self-explanatory, but infrared is on the electromagnetic spectrum. So you think back to when we were talking about radiation, and we were talking about ultraviolet light and how that's on the one end of the electromagnetic spectrum outside of visual light. Well, infrared is on the other end. So ultraviolet are really, really small wavelengths, and infrared are much, much longer wavelengths. So it lies beyond red at the end of the visible light spectrum. So that means that with infrared film, researchers can record and see what the human eye cannot see, because we can't see infrared. So if we take pictures, that means we can see information that we can't see otherwise. So here is 3 images of the same space that are in different, have different filters or different films on types. So we have color. Also, the roads have been drawn on with digitally, so those are not naturally in the photograph, but they've been sketched on. So we can see that we've got green trees, we have some sort of settlement or something going on here. Then we have black and white, which shows us different contrast. Different things pop out in different ways. Then we have infrared, where now we can see, again, our information shows up in very different ways. The trees are not actually red, but they're actually green, but they show up as red based on their reflection of infrared light. I don't honestly know why you might use one or the other. It's not something that we need to know. We're just, at this point, we're just understanding that there are various options. So Canada has 5.5 million square kilometers of forests and other wooded lands. So area photography helps researchers monitor the biodiversity of these forests. It is very, very difficult for people to be able to measure or look through all of those areas in 5.5 million square kilometers of forest. That's a lot of wooded area. So be able to take pictures and gather information is really, really useful. So for example, Canada's National Forest Inventory uses aerial photos to make estimates about species biodiversity of trees, as well as gather data about forest health, so like insect damage or disease, and productivity. So using ground sampling and area photography together, they measure a network of sampling points across Canada at regular intervals. By collecting data over time, they can determine the state of Canada's forests. So now we're going to look at the Lincoln index and capture, mark, recapture sampling, specifically that goes along with this, the Lincoln index. So this is used for sampling animals, birds, and fish, because plants and trees are really great at basically just staying where you found them. So they're easy to come back to, they're easy to get a bigger picture because they are not moving. But to be able to sample animals, birds, and fish, this is much more difficult as they are on the move. They don't generally want to be caught. They don't want to be tracked or marked or counted or researched upon. So they don't volunteer that. So this is one method to be able to collect data about moving animals. So it's used to estimate the number of individuals in a population of mobile organisms. So the fact that they are moving organisms, and that we're estimating how many they are without actually counting each and every one. The index is based on capture, mark, recapture sampling. So how this works is that a sample of organisms is first captured using various methods, which we'll talk about. And then we're going to talk about how they're captured first. So first, we capture some animals. So there's different ways depending on what it is that you are capturing. The first one is the aquatic dip net, and this is used to collect aquatic invertebrates in shallow water. So it's swept through the water or pushed through aquatic plants to collect insects and bottom-dwelling organisms like worms and clams. So we're not catching fish, but we're collecting other grubby things from the water. So hopefully my links will be working and we'll be able to see a little bit of a video of how this works. No, this isn't.
So I've got my essay written, and I've been working on it for about
just
a week.
add.
So now I'm going to show you how I use brain.
There we go.
You will collect one DipNet sample per site. Each DipNet sample consists of 2 dip netting efforts. DipNet in the near shore vegetated zone, in water up to 1 meter deep. Sample close to the edge and into the vegetation. Avoid sampling near the bottle traps if possible. Before you take your first dip netting effort, put water in your collecting pans that sit underneath your screen. Place the screen over the trays so that its edges don't hang over the edge of the pans. This way, the critters go down into the water in the pans. Sample in the shallow emergent vegetation zone in water not deeper than 3 feet. Hold the long-handled dip net vertically, one hand near the net and one hand up on the handle, much like you would hold a canoe paddle. Using strong strokes, sweep the net through the water towards you about 3 to 5 times. Be sure to sample into the vegetation near shore. Dump all of the net contents onto the hardware cloth screen. Get everything out of the net. Spread the vegetation and loosen it. Do this periodically for up to 10 minutes. This allows the critters to get down into the water in the pans. After 10 minutes, remove the vegetation. You are now ready for the second dip netting effort. Move to a different shallow area and repeat the process. After spreading out the vegetation for 10 minutes, remove it and pour the water from the collecting pans through your sieve. Be sure to pour the contents over the large pan in case of spilling. Dislodge the leeches and snails that might attach to the pan. Backflush the sieve contents into your sample jar with 95% alcohol. Be sure to get any critters that are attached to the sieve walls. Use 2 jars if critters and debris occupy more than 1/3 of the jar volume. Once your sample and alcohol have been placed into the jar, be sure to label the jar properly. With a pencil or India ink, write the site name, date, type of sample, and number of jars on a heavy piece of cardstock or note card. Place the label inside the jar, then label the outside with tape.
All right, so that shows us how how dip nets work. So it's really, you're just putting in, here's a pretty good picture of the net. You go into the water and you're grabbing bugs and worms and slugs and leeches and things like that to then count and test and track them. Then mist nets are the second type of capturing, depending on what you're capturing. So this is a fine net attached to poles that are set up and stretched out to block bird or bat flight paths. So this is how you can catch some birds, probably not all the birds, but some birds. The nets are so fine, so it's difficult for birds or bats to see them. Then once caught, the birds or bat falls into the net's loose flaps and are quickly removed by researchers. So they don't stay in. So here's a picture that's kind of close up. They don't stay in these nets. The nets are just, the birds get caught in them, and then the researchers come and get them out really quickly. So let's see if this one will work for us.
The following banding techniques are used for our tidal marsh sparrow project and can be used with other songbird species. We use 12-meter long nets called mist nets to capture these sparrows. The mist nets are 2.5 meters tall and are suspended between 2 poles. Since we are in a salt marsh with low vegetation and no trees, we can prop up poles in the soft ground with the appropriate support and tension without using ropes, stakes, or trees to anchor the poles. A very important step in setting up mist nets is making sure the area is clear of any vegetation which can injure birds caught in the net. Since we are in a salt marsh, this is often not an issue. Once the nets are properly set up, we return to our banding station and wait for the birds to fly into the nets. Since the nets are thin and thread-like, it looks invisible, and therefore birds will passively fly into the nets because they cannot see them. Since the nets are often in direct sunlight, we check them at least every 15 minutes. We check every net and make sure that all birds are extracted and that vegetation or insects are cleared out of the nets before returning back to the banding station for the next round of net checks. Our banding station has all the tools needed to process a bird. These tools include calipers, bands, banding pliers, wing cord ruler, and various buffers for our fecal and blood samples. We will also actively drive birds into the nets by running and clapping. We aren't always successful in getting a bird into the net. We corralled this bird into the net. Even when we don't get a bird, we always have to check the nets. Here we successfully caught our female. Unfortunately, playback, which is the use of...
So we're not going to go into more detail. The video goes into more. If you're interested, you can check it out. I'll put it in the show notes and link it in the supplementary videos. But you can just see how the nets kind of work. It's a little bit tricky to see just because they're so fine. That is kind of the whole point. And they obviously, in respect of the birds and not to stress them out, they didn't videoing them really close while they're in it. But now you can kind of see how that works and how these birds are in it in this close-up picture. Then we have helicopter net gunning and darting. So this is often used for larger animals like wolves or grizzly bears. Using helicopter nets are dropped over fleeing animals. Then animals are shot with tranquilizer darts to temporarily immobilize them. Again, I didn't have to find a good video where you could see them actually shooting a net from a helicopter. And then the ones that I could find just seemed more like hunting. I didn't like the ones that I found. So here you can see that someone is shooting a net from a helicopter onto a deer or something to then immobilize them so that they can then check them out. Here is
cutting-edge casino technology in Rio Vegas.
ad.
The owner from Wells Cars Aviation, they do our top of flying for us and our
So this is one, so they're doing some rhinos. So I'm gonna start up from where I wanted. So we're just gonna jump, here we go, back to the helicopters. So you can sort of see, I don't know why I won't,
Run a girl from the research program, get it run it from a helicopter. You have to get in really low, you have to get in really close. So the competency of the pilot is absolutely critical. It's a vital part of our program. Ron is an amazing pilot, knows how to get the job done. That's just a really nice operation and nice people to be able to work with.
The team is ready to go, and communication just came in from the helicopter of the rhino's whereabouts. It's all systems go. I got the camera set and on record, and Kevin drove the team to the location where we had a visual on the chopper, and then we knew the rhinos were close by. Dr. Peter Rogers is using an Excalibur CO2 darting rifle, which shoots a dart at 350 feet per second. This allows the projectile to penetrate the rhino's thick hide and deliver 80 milligrams of butorphanol into the rhino. This is enough medicine to knock out 160 men. The vet wastes no time and makes a perfect shot. Yana, the pilot, radios in and tells us to start our stopwatches, saying the darting of the rhino was a great success. She skillfully guided the rhino with the helicopter towards the road where we were waiting, and eventually the rhino went down within 30 meters of the vehicles.
Now, once the rhino goes down, a lot needs to happen. Everybody's got their own work to do, and everybody knows what to do.
So then they continue to go and show how they then treat this rhino in terms of tracking it and taking some samples. But the helicopter and the dart gun is sort of the key in terms of how they are able to get close enough to this large animal, rhinoceros. And then finally we have live traps. So there are many different kinds of live traps, and they're focused on capturing organisms in as humane a way as possible. So are closely monitored to prevent organisms from remaining in them too long. So similar to the mist nets, they don't want to trap animals and have them being stressed out and hurt themselves. Examples include baited foot hold traps with rubber padded jaws, cage traps, and camera traps used to study shy or nocturnal, which are active in night organisms. So cameras are connected to infrared beams that trigger whenever something breaks the beam. So then that's one way you can study nocturnal animals. So I have a quick video of turkeys being caught in a live trap. Oh, come on, just work. Yeah, all the other ones worked. Sorry, it's entertaining. The turkeys are fun. I want you to see the turkeys. Let's see if I can. Oh, again. Okay, so we don't need to watch them set up the trap. This is totally not my video. We don't want hunting.
Our primary focus is to look at the habitat use of Rio Grande wild turkeys in South Texas. There's a lot that goes into it, but it only takes you a couple seconds to have.
And go the turkeys.
When the net goes off, our primary goal is always the safety of the bird.
There goes the net.
Top. It's pretty exciting when that net drops. Any birds on the edge? That corner? It is very fast and free. We're not underneath because we need to. We try to do it as fast as we can and reduce stress on the birds. It's really going to show. Okay. It's quite a rodeo sometimes.
All right, so you can see how the lab trap works to get the turkeys. So there's the various ways that animals are captured. So then the organisms are marked and released back to mingle with their populations. So once they've been captured, they get tagged in some way. And then later, so this could be hours, weeks, months later, depending on it, they capture a second sample, probably the same way they captured the first. And then individuals from the second sample that are not marked, so none of them are marked, but they calculate the ratio between the marked and the unmarked organisms in order to estimate the total number that they have altogether. So this is done through this population, this formula where it's the total population is equal to the number of organisms captured and then marked in the first sample times the number of organisms captured in the second sample, and then all divided by the number of marked organisms in the second sample. And that gives you an average of how many animals there are in total. So the following conditions must exist for this sampling to work. The population of the organisms must be closed, so there can't be any things that are coming in and out of that group. The time span between taking the different samples must be short compared to the lifespan of the organisms. And the marked organisms must mix completely with the rest of the population in order to really know that you're getting good information from the whole sample. So that's how we sample them, but then how we track and tag them. So sometimes organisms are simply marked for researchers for possible future identification to just see how they're doing and what's going on. So migratory birds are one example, and they're tagged so that their migratory patterns and survival rates can be collected and compared in various parts of the world. They can use alphanumeric labels, so this could be a small metal or colored plastic ring or flag, which is stamped with a combination of letters and numbers, and then recorded. So here are some examples of flags on birds' legs that have numbers on them, or here even in a fish, it's an implant that goes under the skin so that they can track that fish. Then there's also wildlife radio tracking. So some transmitter collar that uses radio signals is tuned to different frequencies that can report individual animals' movement, behaviors, and as well as the population size of their community. So here are some images of various types of animals that have these tracking on them. So you can see these collars on these various different animals, which seems very strange to me, these wild animals that have these trackers on them, these collars on them. I don't know how I feel about it, but anyway. And then here you can see a person using a transmitter to get information. And then the last thing, the way that they measure track animals is from space. So researchers also use Earth observation, which could be EO stands for technologies, to measure and monitor biodiversity. And so EO technologies include individual satellites and global positioning systems, so GPS, just like we use in our cars and on our phones, that are able to collect and computerize images and data from space. So GPS technology involves a system of satellites and portable receivers that are able to pinpoint a receiver's location anywhere on the Earth's surface. All right, so now here are the key questions on page 167, questions 1 and 2. All right, so that is all of our information about measuring and monitoring species biodiversity. So this is wrapping up chapter 6. This is lesson 20. So we talked about sampling. We talked about the different ways of collecting information, either using quadrat, line transect, or aerial photography in terms of sampling stationary plants. Then we talked about the Lincoln Index, which used the capture and the mark recapture method of collecting information. and we looked at aquatic dip nets, mist nets, helicopter net gunning and darting, and live traps for ways of capturing the animals, and then the different tagging ways that you could use to then, which is next, various tagging ways, and then releasing them and capturing them again. And then we talked about the different wildlife tagging tracking. So we talked about the alphanumeric flags and rings, the radio tracking transmitters on collars, and then also the GPS tracking systems, which is using satellites in space. All right, so hopefully you can explain the differences between quadrat, line transect, and aerial photography sampling. You can also explain and calculate the Lincoln index. Sorry, I rushed through that a little bit. I was worried about time, that we weren't going to get through everything. But remember, that is just where to find out the total population, to estimate the total population, you take the number of animals that you, from your first sample that you marked, so the total number of animals that you marked in your first sample, multiply it by the total number of animals that you've captured in your second sample, and then divide that by the total number of marked animals in your second sample. And that will give you an estimation of the total number of animals in that population overall, because it's like you're doing a ratio. You're saying the number, you're comparing the number of animals that you sampled, that you marked, compared to the total number of animals that were marked within your second sample. If you have a hard time with that, let me know. Feel free to reach out to me and I can walk you through it a little bit better, the math of it. And then we talked about the different tracking methods. Hopefully you can describe the alphanumeric, wildlife radio tracking, and GPS methods of tagging and tracking. So that is, then you can do the questions on 169, questions 1 through 13, where you can see you have to do a little bit of math. Not a lot, a little bit of math, but then also continuing just our regular questions about explaining the differences and the similarities of things. So that's a wrap up of lesson 20, chapter 6 again. So we've finished chapters 1 through 6, and we have lessons 21, 22, and 23 to conclude this week, which are chapter 7. So we'll be looking at another different topic than we've been talking about before. And then we will be finished, and then you'll have hand in all of that work, so submit all of your work by June 10th, but also earlier, so that you can also do your culminating assignment that you'll need to do before June 10th as well. If you have any questions or concerns about anything, if you're struggling with something, if you're not sure if you can get it done and you want to talk about options, please reach out to me. My number is 807-737-1488, extension 2209. You can also call us toll free at 1-800-667-3703. You can email me at bronwyn.slate, and that's spelled BRONWYN.SLATE@nnec.on.ca. You can connect with me through Facebook at Slate Wahsa, and you can watch all of our lessons on YouTube, which is also called Slate Wahsa. I'm here at the office Monday through Friday, 9 a.m. to 4 p.m. We are not open to the public yet. That won't happen this year, maybe hopefully next year. But if you want to reach out to me, that's the best time for me to either catch me on the phone, or I will get back to you really quickly if you email me or Facebook me, generally, unless I am teaching or in another meeting. So feel free to do that. Yeah, thank you so much for joining me. I hope this was helpful. Enjoy your day, Witch.